Today we're going to be doing 1-3 and 1-4. A lot of 1-3 you already know again, so I'm going to review it rather quickly. So 1-3, real numbers. Some of the numbers you already know are whole numbers. Starts at 0, 1, 2, 3, continues counting up. These numbers in the set, it's in brackets, are elements. Natural numbers, sometimes called counting numbers, are 1, 2, 3, because if you count with your fingers, you always start at 1. So 1, 2, 3, going up forever. These are a subset of whole numbers. So we've got sets and subsets. Integers, they're positive and negative whole numbers, so they continue on to the left forever. That's why we have the dots going on to the left. So if you start at 0, -1, -2, -3, -4, continuing on down. 0, 1, 2, 3, continuing on up forever. That's our integers. So then we have rational numbers. Rational numbers are any numbers that can be written in A over B form. So anything that can be written as a fraction are rational numbers. If it's a decimal that ends or repeats, it is also a rational number. So examples of rational numbers: square root of 4, because that's 2. 5 would be a rational number because that's 5 over 1. So I could write that as a fraction. 3/4 is a fraction already. It's a decimal 0.85. Oh, 0.75. I was going to use the example of 0.85 as one also, but I used 0.75, 3/4. 2/3 is a fraction, and if you write it as a decimal, it repeats forever as 0.6 repeating. So those are all different types of rational numbers. Irrational numbers are anything that are not rational. So you can't write these as fractions. If they're a decimal, the decimal never ends, it never repeats, like pi. 3.14159 never ends, never repeats. Square root of 5, if you don't know the square root immediately, it never ends or repeats. So our real numbers include both the rational and irrational numbers. So you're going to be looking at those type of numbers, of real numbers, including every type of number. So in looking at those numbers, we're going to be talking about inequalities. That is, are less than, greater than, less than, equal to, or greater than or equal to. So those symbols, when it's less than, it's just continuing to the left on a number line. Greater than, it's continuing to the right on a number line. When it means it's equal to, on a number line you would fill in a solid circle. If it's just less than or greater than, you would use an open circle. So 5 is less than 7. If we had x is greater than or equal to 10, we want to be going greater than our 10, and we want to show that it's equal to, so we'd use a solid dot there. If we had x is less than 8, we'd have an open circle at 8 because it does not include it, and it would be going less than. So if we're putting numbers in order from least to greatest, we want the smallest. So I would look at negative numbers. So there's -3 and -60/11. So if we wrote -3 in 11ths, it'd be -3 times 11, so it'd be -33/11. So that means, because this is -60/11, that is our biggest, that is our smallest number. That negative 60 would be to the left of negative 33 elevenths, so it would go on the left side. So now we have square root of 31, square root of 11, 5.5. So if I think of my numbers squared, 1 squared is 1, 2 squared is 4, 3 squared is 9. So this is a little over 3. 4 squared is 16, which I am less than 16, so this has to be between 3 and 4. So we'd have square root of 11 next. Square root of 31, well, I know 5 squared is 25, so this is bigger than 5.5. And 6 squared is 36, so it's closer to 6 squared than 5.5. And I'd have the numbers in order from least to greatest. When you go about simplifying a square root, we want to take into consideration which numbers we have. So, square root of 2,500. Well, if I look at that number, I have 25 times 100. I know the square root of 25 is 5, square root of 100 is 10. So I can look at the square roots separately and then multiply them back together for 50. If there is a square root that you don't recognize and don't right away know what number is squared to give you the number, start factoring. So square root of 225. Since it ends in 5, it's a multiple of 5. So I would factor out a 5. So 5 times something has to give me 225, which it would be 45. 45, I remember, is 5 times 9. So now I've broken it apart to 5 times 5 times 9. Well, square root of 5 times the square root of 5 is 5, or if you want to rewrite it as 25, you can, but square root of 25 is 5. Square root of 9 is 3, so that would be 15. And you have simplified the square roots. And that's all for 1-3. We're going to move on to 1-4. 1-4 properties. The reason we start talking about properties here is because you're going to need them in geometry. Geometry, we label everything, tell every step of why we do certain processes. So we start out with simple ones that you already know. Addition property. If you have an equation, if A equals B, then A plus C equals B plus C. When we go to solve our equations, whatever you add to one side, you have to add to the other. What lets us do that is the addition property. We also have subtraction property. You could probably even start writing it down before I even say it. If A equals B, then A minus C equals B minus C. Again, whatever we subtract from one side of the equation, we have to subtract from the other side of the equation. Two more properties. Multiplication, and again, if A equals B, then whatever we multiply one side by, we have to multiply the other side by. So A times C equals B times C. Division, whatever we divide one side by, we have to divide the other side by. So if A equals B, then A divided by C equals B divided by C. Commutative property is next. If A equals B, then B equals A. We can switch either side. So if we look at our properties of addition, subtraction, multiplication, and division, if you were thinking about taking our numbers and switching them, commutative property only works with addition and multiplication. An example, 3 plus 5. We can switch that and get 5 plus 3. Well, this side's 8, that's 8. If we look at subtraction, 3 minus 5 is negative 2. 5 minus 3 is 2. If we switch the numbers and left the subtraction signs in between, they are not equal to each other. Again, with multiplication, 3 times 5 would equal 5 times 3. 15 equals 15. In division, if you had the numerator, and if I write it as a fraction, 6 divided by 2, would it equal 2 divided by 6? Well, 6 divided by 2 is 3. 2 6 simplifies to 1/3. So those are not equal to each other. So we can only use community property in addition and multiplication. If we look at associative property, what associative property is, it is a regrouping of things. So in addition, if we have 3 numbers added together, we could group A plus B. Add those together first, then add C. And that would equal A plus, if we added B plus C together, then added the A. We would remain equal. Same in multiplication. We take the first 2 numbers and multiply them first, then multiply them by the third. It would equal multiplying the last 2 first times the first number. I didn't do an example of that, so let's just quickly go. 3 times 2 times 5. 3 times 2 times 5. So if I take 6 times 5, that's 30. Well, if I take 10 times 3, that's also 30. So you could group them with whichever is easier to multiply. I like 10 times 3. Identity. If you want to keep your identity, you're not going to change anything about you. So in addition, what allows you not to change your number is adding 0 to it. In multiplication, what keeps the number the same is multiplying by 1. And then we have 2 last properties of 0 property. Anytime you multiply by 0, you end up with 0. And multiplication property of -1. Anytime you multiply through by a -1 times an A, you get -A. And that ends all of 1-3 and 1-4.